Oh, what a mess. You're probably looking at this mess and you're thinking, oh my goodness, I do not want to get involved with this. And I've got really good news for you. You really don't have to get involved with this at all. Okay, once you go to a store and you know what you want and you pay a modest fee, they'll build the computer up for you. Don't worry about it. But I thought it would be a good idea that I would just quickly show you the parts of a computer, because it really is very interesting, you know, once you grasp it. And it will only take just a few moments to see how this thing works. And what's amazing is that, you know, I've been at this for like 20 plus years, and you know, granted, the technology has advanced and, you know, obviously things get very interesting over the years, but the basics of how these things work hasn't really changed that much, not at all. So I'm just going to give you a really quick tour of what's going on in here. And again, when it comes time for buying your computer for virtual reality, you don't have to worry about much of this at all. They'll know exactly what you need. You know, you just pass on, you know, what you're looking for, and they'll be able to build everything for you. This is just some basic information, just so you have an understanding of how things work. Now, this I think is really something. So let me show you. This is what's called a motherboard. Okay, this is the basis of a computer. All right, everything that you plug in, like your hard drives, your CPU, your graphics cards, your memory, everything goes on this. This is literally the motherboard, okay? Now this is, you know, with all the time that's gone by, I mean, if you just do a quick comparison, you know, not much has changed, okay? I mean, this is just, I mean, the technology has advanced, but the nature of how things work, again, they haven't changed that much. Now, something really cool, something I wanted to point out. Yes, okay. So if we look on this old motherboard, okay, this right here is what's called the CPU, or the central processing unit. There's some gunk on that, and I'll explain what that gunk is for in just a moment. So the CPU is really responsible for most of the core calculations done by the computer. Okay, that's really the brain of the computer. Now, the reason why I think it's funny is that I should have put it here, but the thing about a CPU is it gets very hot. Okay, it does so many millions and millions of calculations per second that it gets extremely hot. And over the years, they have what's called heat sinks. Okay, and what the heat sinks do is they go on the CPU and they literally, you know, push the heat away, either through fan or what's called water cooling. They have all kinds of technologies to make it happen. And it used to be that a heatsink was maybe, you know, this big, okay? Well, the modern day CPU is very much the same size, but look at this. This whole thing is the modern day heatsink. And this is a very basic thing. So even though the CPUs, like the brain of the computer, have remained very small, I just think it's incredible that the processing has become so advanced that the heat coming out of these things has become so high that they've had to come up with all kinds of cooling measures, especially ones as big as this. And this is a basic thing. So that's the brain of the computer. Over here, these are the memory. This is the memory, or what's called RAM, or random access memory. So whenever you load software, whatever you're doing on your computer, it gets stored in here. Okay, this is when the computer loads up your software. It gets stored in here, and you know, between the CPU and the memory, that's often where most of the calculations are happening. The memory over the years has become faster. Okay, so it's rated as far as, they call it DDR RAM, so DDR4, 5, and it goes up the scale depending on the platform that you're using. Not much has changed over the years, okay, but I mean, as far as the design concepts are concerned, it's just the technology's advanced. So the memory plugs in here into what's called, they call them DIMM slots, okay, but just so you know what it looks like on a motherboard. So again, very much the same. The technology's advanced a bit, but again, it's same, very similar design, okay? Next, we have the graphics card. Okay, this is an AMD 390X graphics card. Okay, look how big that is. All right. I mentioned that the CPU is the brain of the computer. Well, this is its close brother. Okay. So what happens is the CPU, it sends instructions, says, oh, okay, this is what I need to do. And then the graphics card, when it comes to, making all that virtual reality magic happen, a lot of that work happens right in here. And just look, it's even got its own power connectors. Okay. It needs more power than a CPU. And look at the size of this thing. A lot of this is all about cooling. There might be like one or two small wafers on this, but the rest of it is just, look at this. These are like vents and ways to for the heat to blow off. And one of the things is when people buy graphics cards, one of the things that they look at isn't just how fast the graphics card is. They also look at, efficiency as far as electricity. I mean, if this is really blown up there, it could use up a lot of power. But that's what's needed to drive, modern day virtual reality. It's really exciting stuff. And, something else that's really cool is in some motherboards, okay, you could actually take more than one graphics card and put them in on the same motherboard, and they cooperatively work together. So NVIDIA has a platform which they call SLI, and AMD, or Advanced Micro Devices, or AMD Radeon, they have their platform called Crossfire. So if I had two of the identical AMD graphics cards on the same motherboard, they could be working together cooperatively to produce great virtual reality graphics, and faster. So ideally what happens is if you have two graphics cards, and if you really want to go there, you could have three graphics cards, you could get close to double, perhaps close to triple the performance you would get with just one. It usually doesn't add up to quite double or triple according to the number of graphics cards, but it is a significant increase in performance, and it's also a way that if, let's say, you have a graphics card and suddenly it's, with time it's not performing quite as well as, let's say, a newer card, what some people do is they buy an additional graphics card to compensate for that difference. So there are ways to save money just by adding an extra graphics card and getting additional performance to bring your computer up to more modern times. Now, other things to look for. So this is what's called the PSU, or the power supply. Very simple. I mean, like most electronic devices, they have a power supply. This one is rated at 650 watts. I should have probably gotten one a little stronger, 750 or better. Why is the wattage important? Well, what happens is as you add additional graphics cards and additional hard drives and DVDs and electronics to your computer, they draw more power. And you need to have enough wattage there to support the equipment, or what's going to happen is your power supply could eventually burn out because it's doing more than it was designed to. But just so you know, when it comes time to changing a power supply, if you have to, they're very inexpensive. It's not a huge expense. I'm kind of kicking myself for not getting one a little bit stronger, but that's not a big deal. 650 watts is quite good for my needs. Now, next up is the hard drive. Looky here. Look right here. This is there's a hard drive in there. That's an SSD hard drive, or what's called a solid state hard drive, or a solid state drive. And let me just give you a comparison here. So this is a modern day SSD card, okay? This is a traditional mechanical hard drive. Look at the size difference, okay? So what's the difference? Well, again, this is a traditional drive, okay? It's based on a spindle inside. Like there's a couple of magnetic platters that they spin in a circle, and there's a head that affects the magnetic film, and it stores your data very quickly. Okay, and it spins very fast. Most hard drives, if memory serves, spin at like 7,200 rounds per second, or per you have to look it up, but 7,200 actually per minute. But anyway, mechanical. Okay, and this has been the workhorse for computers for like decades. Okay, and it's going to continue for some time. Now, a more modern technology is SSD technology. And what's amazing about this is it uses something called flash memory. So what this means is there's no moving parts. There's no spindles. There's no platters. All that happens is there's a memory chip inside, or a memory wafer, and it's written and read from very, very quickly. Now, the catch with an SSD card, the reason why you still have both technologies is this is somewhat more expensive. This is just a 256 gigabyte version. You could probably get 512 gigabyte versions for what I paid for this. I mean, you get maybe $150, whatever it is. But so it's smaller storage space. But the thing is, it's extremely fast. So what a lot of computer manufacturers do is they sell these hard drives because it's great for operating systems, because that's what loads up fast. That's where you need all the performance. And often what you do is you get a traditional hard drive as your secondary hard drive, for loading up your traditional applications. I usually don't recommend doing one or the other. I like to recommend doing both if you can afford it. Really exciting stuff. And over here we've got, you can't really see it. It's black on black here, but this is just a DVD, or you get a Blu-ray player. Again, as I said, not much has changed with this technology over the years. It's primarily been about performance. Now, something to be aware of, as I mentioned, the motherboard. Okay, this is that giant piece where everything plugs in. There have been some interesting advances with motherboards over the years. So in this case, we have a dedicated graphics card, and of course we have the CPU and so on. What's happened with modern motherboards is they've added more features to them. Okay, so if you had to, now I'm not speaking to virtual reality, okay? If you just wanted a very simple computer, you could probably, in many cases, you could get away without this, because the motherboard would have its own little graphics chip built in. But just be aware, it would not be at all powerful enough to drive modern day virtual reality, which is why you need a graphics card by AMD or NVIDIA. And for virtual reality, modern day virtual reality, it's recommended to get an AMD RX 290 or better, and NVIDIA, it's a GTX 970 or better. But again, don't worry about this. It's listed elsewhere in the guide. I'm just giving you an idea of how this stuff works. And the other thing that motherboards do is they tend to have audio built into them. So if we look over here, see, look at all these plugs. This is all stuff coming out of the motherboard. So you've got your USB connectors. Those are actually very important. When you're shopping for a motherboard for virtual reality, make sure that it has what's called USB 3.0 or better. But again, that's all standard stuff. One of the advantages with upgrading a computer is, a lot of this stuff is standard at the most basic level. This is where, the audio channels come out. If you have speakers or surround sound, you've got some video card connectivity here, whether it's HDMI, which is the same stuff you use for your television, or DVI, which some computer monitors support. Again, it's all coming out of the motherboard. But not to cause confusion, but when you have a dedicated graphics card, which you will have for virtual reality, all that video stuff's handled here. I'm just letting you know that, all the advances, how much is stored on motherboards these days, and it's very inexpensive. And what else would I show you here? So the rest is just, a lot of it's flash. I mean, you've got, flashy stuff. You've got LED lights, and you got fans blowing the air around to make sure that everything stays cool. There's a lot of processing happening in here. But I just wanted to map it out, how it works, and now you know. And when you go to the store, you have your list of what you need as far as what kind of CPU you want, what kind of graphics card you want, and they will know how to match everything up that it works properly together. You don't need to know every little specification. I just wanted you to get an idea of how this stuff works. And one more recommendation. I mentioned earlier that you could have more than one graphics card on a single motherboard. Okay, so I said that with NVIDIA it's called SLI, and with AMD it's called Crossfire. It used to be that when you bought a motherboard, you could only get one or the other. You basically had to choose, all right, if I want cooperative graphics cards, I want to go with the NVIDIA brand, or I want to go with the AMD brand. Well, now you can get modern motherboards, if you choose to, that support both brands equally. And I would recommend asking for that because it's inexpensive. It's not a big add-on for a motherboard. So it's not like the old days. You could get very inexpensive motherboards that will meet all your needs. Anyway, that's everything. So enjoy.